you guys have learned. Can anybody tell me what that is?
Object's acceleration depends on its mass and on the net force acting.
Yeah, that's it. Alright, so we say that force equals mass times acceleration. That's exactly what we said, and that's what we're going to be using in our lab. Alright, so in our lab, we will have one object, it's going to be a wooden block, and on it, the forces that are acting on it will be gravity pulling it down, a normal force pulling it up, which is just anything that's on like this stapler is on a surface, so it's normal force pulling it because the surface is up. So, yeah. And then the force of friction, because you'll be pulling. So
Okay, so the force of gravity on Earth, the gravity that always changes what planet you're on. But for Earth, it's negative 928 meters per second squared. So anytime that you see, and then if you want to find the force of gravity on an object, it would be the force of gravity equals mass. So yeah, that's the consistent. You're always going to use negative 928 for so. Why would that?
because you're going down.
Okay, after that.
So we know that. Okay.
Okay, and the normal force. The normal force is the force that acts on an object that's set on the surface. And that's the opposite force of gravity. Well, F would be negative as a random positive. So yeah, it's always going to be the opposite, and they're always like equal to each other. So, yeah.
And this is because you have the sum of forces, so that's just like, which what you see here is normal force plus the force of gravity is mass times acceleration. But if this acceleration is zero and you're going at a constant speed, which is what we're doing in our lab, then they'll just be opposite. And that's why that's friction. So friction is if you push an object, it'll just keep going. Except if there's friction, and then it'll slow down and stop, which is really great when you're driving cars. So friction is the force of friction equals mu, which has to be called out mu, times the normal force. And times the
It
normal
looks like an upside down H. When you're drawing it, it's reading that.
And since the normal force is the same for objects, because they're all going to have the opposite force of gravity, mu is the thing that makes a surface have a different friction than different force of friction than other surfaces. Which is what we use. And that's,
Yeah, again, mu is essentially
so yeah, that is our lab. We will have 3 different surfaces. We're going to use this desktop. We have some cardboard and some felt, and we're going to be pulling a wooden block using, that's called a Newton meter. And what you're going to do is you're going to attach this with a hook on your block and pull it at a constant velocity. So you're going to know you're going at a constant velocity because then the Newton meter will read the same thing the whole time. If you accelerate, it'll mess it up because you're not going to have down precision. So you're going to be doing that on different surfaces and recording your data to find out the different views of the surface.
Yeah, so use your wood block, use your Newton meter. Yeah, so very simple. And so you have the desktop, your felt, you can just lay it down flat on top.
So if you guys want to come grab your materials, and you can spread them out, you can use the ground or the desk once you're done using that as your surface. You can open up this, and they're all folded up. So if you guys want to open that.
Well, this lab on Newton's second law and friction lab came at a great time. I had a former student who wanted to use a lab experience for her AP physics class. And I was open to it because this is the last unit or chapter of the year.
Hook the Newton meter up. Nice. And you're going to pull at a constant speed. So take your hand off it and and move it like that. See how it's kind of just a little bit before zero? That's what you want to write down. And you want to do that 3 times just to make sure it's consistent. Block off and
Side note, everyone, you need to know what the mass of your wooden block is. So there's 2 weights on either side of the room. So before you start, or maybe like during it, you want to have someone go up and kind of figure out how much it weighs. That would be important for when you're solving for you. Cool,
We're trying to understand the coefficient of friction, something they won't get until high school. But using the Newton meter and the different surfaces, I think, gave them an opportunity to understand how scientists conduct experiments. They had to move the block, they had to record it in a data table, and get the best average that they could. In addition, the plug and chug of actually plugging in their data into the formula was great because they had a chance to use their math skills in manipulating algebraic equations.
Ready?
Alright.
Whoa, it's like 0.5. It's like 1. Oh my god. Oh god. Okay, let's do it again. So that was like 1.
So what we were doing in the lab is we designed a lab to demonstrate the force of friction and how the coefficient mu on friction works and how it differs with each surface, to show that friction is different for each surface. Even if you have the same mass, you have the same object, which is what they have. They have a block, which is constant throughout each group, but they're using like the desk surface or felt or cardboard in order to show that friction is different.